Let us solve OpenStax University Physics. Volume 1, Chapter 2, Problem 38. You walk 18.0 meters straight west, then 25.0 meters straight north. We need the displacement vector, how far the ending point is from the start, and the direction of that displacement relative to the positive x-axis. The most important work happens in the diagram, especially when we determine the direction. Start by choosing axes. The problem specifies that positive x points east, so west is negative x. We use the usual positive y direction toward north. The first displacement therefore has x component, negative 18.0 meters. The second has y component, positive 25.0 meters. You may keep the lakes themselves positive while drawing, but the vector components must carry the signs set by the coordinate axes. The displacement vector points directly from the starting point to the ending point. It is not the two-leg route itself. In unit vector notation, displacement equals the x component times I hat plus the y component times j hat. Substituting the signed components gives negative 18.0 I hat plus 25.0 j hat in meters. The signs tell us the direction. The units apply to both components. To find how far the ending point is from the start, use the right triangle made by the two component displacements. The displacement magnitude is the hypotenuse. By the Pythagorean theorem, d squared equals 18.0 meters squared plus 25.0 meters squared. Taking the square root gives 30.8 meters. Squaring removes the component signs, as it must, because a magnitude is non-negative. Here is the common trap. If we type y over x directly into inverse tangent, the calculator returns negative 54.2 degrees. That angle points into the fourth quadrant, but our displacement clearly points west and north, in the second quadrant. Inverse tangent alone does not reliably identify the quadrant. The diagram is what tells us which geometric angle the problem is asking for. A reliable method is to find the acute reference angle from the actual triangle. Using the positive side lengths, tangent phi equals 25.0 over 18.0, so phi is 54.2 degrees. The requested direction is measured counterclockwise from positive x. The positive and negative x directions form 180 degrees. So theta equals 180 degrees minus phi. The direction is 125.8 degrees, or about 126 degrees. The displacement vector is negative 18.0 I hat plus 25.0 j hat meters. Its magnitude is 30.8 meters, and its direction is about 126 degrees counterclockwise from positive x. The reusable habits are simple. Choose the axes, draw the component triangle, and make the final angle agree with the actual quadrant. A calculator supplies a number. The diagram tells you what that number means.